So today we're going to learn how to graph a quadratic equation using a ton of different points. So before we get started, I just kind of want to take a moment just to look at a parabola and kind of identify what the points are and how to find them and everything else. All the important things that you need to know about a quadratic graph. So first of all, let's just label the points. So at the very, very bottom here, we have this point right here. We know that's called the vertex. Okay? On the right side over here, that first point, we have our y-intercept. Across from the y-intercept is a point called the symmetrical point. And because a parabola is symmetrical, it's pretty much, we can cut it right down the middle, and we should have points on equal sides. And we'll get into that a little bit later. And there's a couple other things that I want to point out. We have these 2 points on the x-intercept, on the x-axis, so we're going to call these the x-intercepts. You got to be careful because these x-intercepts have a ton of different names. So graphically we call them the x-intercepts. However, your calculator calls them zeros. Okay. When you're asked to solve a quadratic, you're looking for these points. So we can call them solutions. And us old people call them roots. So regardless of what we call them, x-intercepts, zeros, solutions, or roots, just remember that we are looking for where the graph crosses the x-axis. And then we have one more aspect of the quadratic equation. So if you look at a parabola, we talked about a parabola being symmetrical, which means I could cut it right down the middle, right through the vertex, using a vertical line. Okay? And that causes symmetry. So we're going to call this the axis of symmetry. Now what this means is no matter where you have, let's say I have a point right here on the parabola. If you notice, that spot is 2 away from the axis of symmetry, which means I should have a symmetrical point right on the other side. So if that's 2 away, if I go 2 to the other direction, I should have those points. So those points would be considered symmetrical because they're both the same distance from the axis of symmetry. So just looking at this, we have a ton going on here. We've got 5 vocabulary words that you need to know. The vertex, the y-intercept, the x-intercepts, the symmetrical point, and the axis of symmetry. All of these points you guys need to know. And as we talk about them, you need to know how to find them. So let's figure out some of these formulas as to go through it. Okay. The major formula that they give you is the quadratic formula. Okay? And we talked a little bit about the quadratic formula the other day, so I'm just going to write it down. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, the quadratic formula will find the x-intercepts for us. Which means, what are the other vocabulary words? It could find the zeros, the solutions, or the roots. Okay, that's the first one that you guys need to know. Okay, the second one is how to find the vertex. In class the other day, we talked about completing the square, putting something in vertex form. Well, there's a difference between the vertex form and the equation of how to find a vertex. So there's another way that we can actually find the vertex. Okay, and that formula is x equals the opposite of b over 2a. And if you actually look at the quadratic formula, it's kind of embedded within it. So you have, oh, get that out of there. You have the opposite of b over 2a right here. So if you know what the quadratic formula is, you also should know what the vertex is. Okay, that's the second one. You need to know how to find the y-intercept. Now, believe it or not, this is a very, very simple one to find. If I have a standard form for a quadratic equation, it's ax squared plus bx plus c. And I ask you to find the y-intercept. That means you have to put in 0 for x. Well, if you put in 0 for x, you're going to get a times 0 squared plus b times 0 plus c. 0 squared is 0, b times 0 is 0. You just get the c value. So that c value right here, that's always going to be your y-intercept. And then you always put in 0 for x. So your y-intercept should always be the ordered pair 0c. Now there's two other things that we have to talk about. So I'm going to scroll up to the top, come back up here. That is the symmetrical point and the axis of symmetry. Well, the symmetrical point, we're just going to use logic to figure that out. So I'm going to come back to that later as we do some examples. But if we look at this axis of symmetry, we talked about this before. It's a vertical line, right? It goes straight up and down. So how do you write an equation of a vertical line? X equals a number. Okay? And now that number is going to change depending on where that line crosses the x-axis. So for example, if I go back over here, if I'm looking at the graph that I just drew in the past, that vertical line would go right through here. Okay, so it crosses the x-axis at -1, so this would be, the x-symmetry would be x equals -1. Alright, so just depending on where it crosses the x-axis, that's where your equation is going to be. Okay, so now that we have all of the formulas and equations, let's do a couple from start to finish so we can kind of show you how to use this. So I'm starting with the equation 2x squared plus 3x minus 4. And I'm just going to show you guys how to figure these out as we go. Alright, actually, you know what? Let me make it a little bit easier here. Let's change that 2x squared. Let's make it plus 4x. You'll thank me later. Okay, so first problem. Let's do the x-intercepts first. Okay, so to do this, we need to do the quadratic formula. So I'm going to write it down just to make sure I have it in front of me, and so you guys can see it too. Okay, now if you notice, in order to do this formula, I have to know what the a, b's, and c variables are. So when I'm looking at my original equation, a is always next to x squared, so my a value is 2. B is always next to x, so my b value is 4. And c is the constant. Don't forget to keep that negative in there. So c is -4. I'm going to put these values into the quadratic formula. So x equals the opposite of b. Well, b is 4, so the opposite of that would be -4. Plus or minus the square root of b squared. So I come back up here. 4 squared is 16. Minus 4 times your a value, for me, which is 2, times your c value, which is -4, all divided by 2a, or in this case, 2 times 2. Okay, so I'm going to do everything in the square root first. So x equals -4 plus or minus the square root of 16. And if I go up here and I count my negatives, I got a negative here and a negative here. 2 negatives are going to give me a positive. And 4 times 2 is 8. 8 times 4 is 32. All over 4. X equals -4 plus or minus the square root of 48 over 4. Okay? Well, 48 is not a perfect square, but I can reduce 48. I can break it up into 16 times 3. So we got to reduce that square root. So this becomes x equals -4 plus or minus The square root of 16 is 4, so this becomes 4 root 3 all over 4. And we have to reduce these. Both of these numbers are being divided by 4, so I have to reduce them both. So the first one I have to look at, negative 4 divided by 4. So I get negative 1. Okay? Next, I have to do the other side. So this becomes plus or minus, well, 4 divided by 4, that's just 1, so this becomes 1 root 3. Okay, so those are my answers. Now, I asked for them as x-intercepts. And anytime you write an intercept, you should put them in ordered pairs. So you would have two x-intercepts. It's negative 1 plus root 3, comma 0, and negative 1 minus root 3, comma 0. These are the answers I'm looking at. The problem is, you don't know where on the graph these go. So if you wanted to, you can put these into your calculator and give me some decimals. Okay? But just make sure on a quiz or test you give me the simplified version without decimals. Okay. So just to make sure I get this number right, let's type it in. So I'll do negative 1 plus square root of 3. Okay, that's about 0.73. 0.730. Okay, and then I have to do negative 1 minus the square root of 3. When I do that, I get about negative 2.73. Okay, so now that I found these, I'm going to go onto a graph, and I'm going to actually graph these. So let's make a nice big graph. Okay, as before, I said I have one about 0.73. So there's one x-intercept. My other one is at negative 2.73. So there's going to be my other x-intercept. Okay, x-intercepts are done. Alright, so now we're finished with x-intercepts. Let's go on to finding the vertex. Okay, now to use the vertex, we're going to use the formula x equals the opposite of b over 2a. Okay, so as I go through this, actually let's use a different color. Okay, my b value is 4, so the opposite of b should be negative 4, over 2 times my a value, or 2 times 2. Okay, that'll give me negative 4 over 4, which is negative 1. Alright. Now, this is just an x value. So I know that my x value is negative 1, but I don't know what my y value is. So how do you find that out? Well, the way to do that is just to take your answer, negative 1, and we're going to put that back into the original equation in standard form. So the original equation was y equals 2x squared, let me make sure I get this right, plus 4x minus 4. So I'm going to put that negative 1 in for my x's. So 2 times negative 1 squared plus 4 times negative 1 minus 4. Okay, this will give me 2. That'll give me minus 4 minus 4. And when I combine all of them, I get negative 6. Okay, there's my y value. So my vertex is the ordered pair negative 1, negative 6. So this is what I'm looking for. Okay, so let's go down to our graph and plot that point. So at negative 1, 1, 2, 3, 4, 5, 6. There's my vertex. Alright, almost done. So, I have my x-intercepts, I have my vertex. Now let's find the y-intercept. Okay, and as we talked about before, the y-intercept is just the c value. Okay, so when you look at your c value, up at the top it's -4. So, -4 is the y-intercept, and to find a y-intercept you put in 0 for x. So there you go. We're all done. That's a nice and easy one. 0, -4. So let's scroll down to that. 1, 2, 3, 4. And where's my y-intercept? Okay. So I can actually already see half of my parabola. So if I plot these points, you guys can start to see that U shape take effect. Now the other parts, a couple other parts of this that we need to find. So we haven't found the symmetrical point. We'll put that under number 2. Okay, and we also haven't found the axis of symmetry. So let's do this first. Let's find the axis of symmetry. If I took a vertical line right through my vertex, that's my axis of symmetry. Okay, so I'm going to call it AOS for axis of symmetry. It's a vertical line, so we write a vertical line as x equals a number, and this vertical line crosses the x-axis at -1. So there's my axis of symmetry, x equals -1. Okay, the next point is the symmetrical point. I'm going to call that SP. It's going to be straight across from your y-intercept. Okay, so if you notice, I've got some symmetrical points already. If here's my axis of symmetry, look at my x-intercepts. It's 1 and then an extra 0.73. If I go the other way, it's 1 and an extra 0.73. These things are the same distance from the axis of symmetry. That means the other points should also be the same distance. Well, from the y-intercept to the axis, that was 1 spot. So if I go 1 more spot, I find my symmetrical point. And just make sure you write that ordered pair down. It's at -2, -4. Oh, writing the wrong number. -2, -4. So those are our last two. We got our axis of symmetry, and we have our symmetrical point. So now I can finish by drawing in the rest of the parabola. Now your worksheet will have one other thing on there that's a little bit different. Okay, it'll say something like this: find the max or minimum of f of x. Okay, now in the past we talked about this. The max or the minimum references the vertex. Right? It's either the highest point or the lowest point on the graph. And f of x is just a fancy way of writing y. So what they're asking you to do is find where the y is of the vertex. So for our case, if we look at this equation right here, this parabola, there's my vertex. It's at the very, very bottom, so this is considered a minimum. Okay, and what's my y value here? 1, 2, 3, 4, 5, 6. It was at -6. So my lowest y value is at -6. So there's the answer to that question. Okay, now, as you're working on this worksheet, you have some situations that could arise. Okay, for example, what happens if I was working on this problem? 4x squared plus x plus 3. Okay, now when you were doing the quadratic formula, if I'm looking, my a value is 4, my b value is 1, and my c value is 3. So as I plug these numbers in, x equals the opposite of b plus or minus the square root of b squared, which is 1, minus 4 times a times c all over 2a, or 2 times 4. Now, if I'm just looking into the square root here, what you'll notice is I'll get 1 minus 48 over 8, which means I'm going to get a negative number in the square root. I'm going to get the square root of negative 47. Okay, so what does that tell me? Well, the quadratic formula helps you find x-intercepts. Okay, so if you ever get a negative under the square root, it doesn't mean that the parabola doesn't exist. It just means that there are no x-intercepts. Well, any real x-intercepts. We're going to find these later, but these are going to be imaginary intercepts. Okay, so you can still have a parabola. So what that's going to mean is, what's going to happen is maybe your vertex is above the x-axis. But if this graph opens up, you still have a parabola, it just doesn't intersect with the x-axis. So that could happen. Okay, so for right now, if you ever get a negative under the square root, all you have to do is write no real solutions, or no real x-intercepts. Okay, we'll talk about how to find those later in class tomorrow. But I just wanted to bring that up in case it does happen. And it will happen every once in a while. So finally, we're going to talk about how to realize that how many solutions you're going to have. If you are going to have x-intercepts, or if you're not going to have x-intercepts. So there's actually 3 different possibilities that you can run into. Okay? So you could have a graph, a normal parabola, that has 2 x-intercepts. It's the x-axis at 2 different spots. Okay, so we call them 2 real solutions. Or, like we just talked about above, you might have a parabola that doesn't hit the x-axis at all. Okay, so you would have 0 real solutions. If you have 0 real solutions, that means both of your solutions are going to be imaginary. And there's one more situation that could occur. There is a situation where you could have 1 real solution. And what that means is that when you draw your parabola, your vertex is going to be on the x-axis. So this is only actually one solution, okay? But we're going to call this a double root. And remind me to talk about that one tomorrow in class. Okay, so our parabolas could be oriented in 3 different ways. To have 2 solutions, 2 real solutions, 2 imaginary solutions, or just 1 double root. And if I'm ever asking how many real solutions there are, you don't have to do the whole quadratic formula to figure it out. Okay, if you look at the quadratic formula, I'll write it out one more time. How did we know if both of our solutions were imaginary? Well, if the square root was negative, we knew that there weren't any real solutions. So all you actually have to do is look at that square root, or what's under the square root. Okay, that's b squared minus 4ac. This is called the discriminant. Okay, and the discriminant tells us how many solutions there are, how many real solutions there are. Okay, so if I give you an equation that looks like this, y equals x squared plus 4x plus 10. And when you are typing this in, so if I do b squared minus 4ac, just do what's under the square root. Okay, my b value is 4, so that would be 4 squared would be 16 minus 4 times a, my a value is 1, and my c value is 10. I'm going to get 16 minus 40. Well, this number is going to become negative. It's going to become negative 24. That means I'm going to get a negative under the square root, which tells me that both of my solutions are imaginary. So we're going to write 2 imaginary solutions. Alright, so now what happens if you have a problem that looks like this? X squared plus 4x minus 10. So when I'm putting in b squared minus 4ac this time, I put in the discriminant. My b value is still 4, so that becomes 16 when I square it. I get minus 4 times a, which is 1, but this time my c value is changed to a negative 10. So because I have two negatives here, that's going to become 16 plus 40. It's going to become 56. No, that doesn't mean I have 56 answers. But if you look at this, let's look at it in terms of the whole quadratic formula. All I got to do is find it now. Okay, so I'm going to have x equals the opposite of b, which in this case was negative 4, plus or minus the square root of 56, all over 2 times a, or just 2. Well, if you look at this right here, you're going to notice that you have a plus or minus. So I'm going to do negative 4 plus a number and negative 4 minus a number. I'm going to go send this equation off in 2 different directions. So because I'm sending it off in 2 different directions, I'm going to get 2 real solutions. Okay, I got one more problem I want to show you. Last equation, y equals x squared plus 4x plus 4. Okay, so in this situation, if I'm putting in b squared minus 4ac, my b value again is 4. When I square it, I get 16 minus 4 times my a value, which is 1, times my c value, which is 4. I'm going to get 16 minus 16. So I'm going to get a discriminant of 0. Okay, so if I look back at this again in the quadratic formula, I would get x equals the opposite of b, which is negative 4, plus or minus the square root, in this case of 0, all over 2a, or just 2. So in this case, the square root of 0 is just 0. Well, if I do negative 4 plus 0, it's the exact same thing as if I do negative 4 minus 0. So even though I'm still doing the plus or minus, I'm still getting the same exact answer. Well, if you're only getting the same exact answer, you're only getting one answer, you're only going to get one real solution. And if you get one real solution, we're going to call this a double root. Okay, so what does this mean, and how can I use the discriminant just to make my life a little bit easier? So if they are ever asking you to use the discriminant, don't mind that bell, it's just ending school. If they ever ask you to use the discriminant to figure out how many solutions you have, all you have to do is plug your values into this equation. B squared minus 4ac. Okay. If you do that, and you get a positive number, any positive number, 1, 2, 65, any positive number, that tells us you are going to have two real solutions. Which means your graph, or your parabola, is going to hit the x-axis 2 times. 1, 2. If your discriminant ends up being negative, any negative number, that means you're going to have no real solutions, which means you have two imaginary solutions. That tells us that the graph is not going to hit the x-axis. So if my vertex was up here above the x-axis, it would open up. So this graph would not actually touch the x-axis at all. Now, the last case scenario is if your discriminant ends up being 0. That means that you are going to have one real solution, which we call a double root. A double root occurs when, again, the vertex is on the x-axis. Alright, so I pretty much showed you everything that you guys need to know about these quadratic equations. I want you to take all of this information that you wrote down, and I want you to do the worksheet for homework. So please do not do the book work, just do the worksheet for homework. And this will be a test to make sure that you guys watch the video all the way through. Alright guys, I'll see you guys tomorrow, and have a good night, and make sure you guys come in to see me if you need any help.